Okay, we're writing a two-column proof here for this. They're telling us that these two angles are supplementary. Angles 2 and 5 are supplementary, and we're trying to prove the lines parallel. Ignore this. They have marks here saying that they're parallel, but we don't know that yet, actually. So we're trying to prove that, so we can't use that, just to be clear. Okay? So what's the first thing that we know? Well, we know that angles 2 and angle 5 are supplementary because they told us that. That was given information. Okay. Now, when I'm analyzing this, I'm trying to figure out where am I going to. Okay. So what I'm thinking is to get from these two angles here being supplementary. Well, I know that if I had same side uh, interior angles right here being supplementary, that would prove the lines are parallel. So how can I get from this and this to somehow this and this? Well, we can go through here with vertical angles, right? We can say angle 2 is congruent to angle 3, and we know that because they're vertical angles. So the vertical angles theorem states that vertical angles are going to be congruent. Okay, so now I've got that these two are congruent. Now, check it out. If I remember what I said I wanted to state in order to get there is that these two angles, angle 3 and angle 5, are supplementary. Well, angle 2 and angle 5 are supplementary, and these are replaceable, right? Like angle 2 is congruent to angle 3, so anywhere I see angle 2, I can just put angle 3. So instead of saying angle 2 and angle 5 are supplementary, I can say angle 3 and angle 5 are supplementary. And how can I do that? Well, I just substituted one for the other. Okay, that is substitution. And now that I know that, now that I know angle 3 and angle 5 are supplementary, the only way that they can be supplementary is if these lines are parallel. So we can now say L is parallel to M. And remember, when you're going, when you didn't start from the lines are parallel, um, but you're using theorems to go backwards and prove that they're parallel, we're using the converse. So we're saying this is the converse of, and what kind of angles are these? These are same side interior angles, okay? So if we knew the lines were parallel, we could say that they were supplementary. But if we're starting by saying they're supplementary, and we got down to there saying they're supplementary, we can prove lines are parallel with the converse. So it's the converse of same side interior angles theorem. That's it.